Hello, in this episode I'd like to finish off the refactoring that I started last episode. So I'm going to begin in the map generator, where I'd like to take all of this threading stuff and move it over into its own class called something like the threaded data requester. So I'm just going to cut this out, and then in Unity create a new C# script, threaded data requester, and I'll open that up and just paste all of this code in there. And also going to take the map thread info struct, paste that at the bottom, and finally grab the two queues, cut those out, and put those at the top. Okay, now one thing that I dislike about this current implementation is that for each different type of data that we want to be able to request, so we've got height map, mesh data, and maybe later on there'll be some others, we have to create a separate queue, we have to create two methods to handle that data, and we also have to have this if statement and loop inside of the update method. So you can imagine if we have a bunch more different types of data, then this is going to get really out of hand. So I'd like to change the way this works a little bit. I'm going to delete one of the queues and also delete the two methods pertaining to that queue and the block of code inside of update that related to it. And I'm going to try and make this code work for any type of data. So starting off, I'll just rename these methods. So instead of requesting a height map, this is just a general request data method. And instead of being the height map thread, this is just a data thread. And the queue is just data queue. And even this map thread info isn't necessarily map info, it can just be thread info. Alright, now to get access to actions and threading and all of that stuff, we're going to have to say using system and also using system.threading. Alright, so previously, when we called this data thread, it would then generate a certain type of data based on which method it was, if it was the height map data thread or the mesh data thread. So it would have this call to some method and it would be passing in all these parameters. But of course, we can't have anything like this anymore because we want to be able to generate any type of data inside this one method. So instead, we're going to have to make it so that when someone calls request data, they have to pass in the method that they want to use to generate that data. So I'm going to represent that with a func of type object. And this is object with a small o, which is an alias for system.object. Don't get it mixed up with Unity engine.object. Those are different things. So I'll just use small o object, and I'll call this the generate data. Alright, so this func is just representing a delegate with a return type of object and with no parameters. So we can use that to generate a data object. Now our callback isn't going to be of type height map, it's instead just going to take in an object parameter. And then into the data thread, I've got to pass in this given generate data method. So over here, this will also be func of type object called generate data. And once again, this will take in an object. And here, we can just say that our object, call this data, is equal to the object returned by the given generate data method. We then just pass that data into our thread info, and the thread info isn't of type height map anymore, nor is it of type height map up here. In fact, the thread info isn't going to be generic anymore, rather it's going to take in objects, like so, and here in the constructor as well. Alright, so that should now roughly work. I'd quickly like to make it a little bit more convenient for other classes to access this request data method just by making it static. Now, of course, since it's static, it can no longer access this instance method, the data thread, so we're going to need to make a static reference to this threaded data requester object, which we'll call the instance, and we want to assign to that as soon as possible, so I'll do that in the awake method. We can just say instance is equal to find object of type, so we'll be searching the scene for an object of type threaded data requester. Okay, so now inside the static method we can access this instance method by saying instance.dataThread. Alright, so I'll save that, and I'll save the map generator as well, and go into Unity, and we've of course got errors from where we were requesting the height map, and also there'll be another one where we were requesting the mesh data. So we want to replace this with our new threaded data requester using the request data method. And now we need to pass in the method that we want to use to generate the data. So that will be heightMapGenerator.generateHeightMap. Currently we don't have access to some of this information though. So to the constructor, I'm going to add heightMap settings, called heightMap settings, and I'm going to replace the mesh world size variable with a reference to mesh settings. Just call that mesh settings. And the reason I'm replacing it is of course just that that value is stored inside of the mesh settings. So now instead of getting mapGenerator.meshSettings, we can just use mesh settings straight off. And instead of mesh world size, we use the given mesh settings dot mesh world size. And we'll have to do that in all cases where we're using mesh world size. So that's just over here and here, I think. Now I'd like to store a reference to the height map settings and the mesh settings outside of the constructor here. So I'm going to create height map settings. Just once again call it height map settings, and then mesh settings, call it mesh settings, and then in here simply say this dot height map settings is equal to the given height map settings, and this dot mesh settings is equal to the given mesh settings. Alright, so getting back to our request data call, we can start passing our parameters into generate height map. So for the width and height, that will just be mesh settings dot number of vertices per line. And then we want to pass in the height settings, and finally the sample center that we calculated. Alright, so that's all the parameters for generate height map. And then there's one more parameter for the request data method, which is our callback, in this case being the onMapDataReceived method. Alright, now currently this won't quite work, and that's for two reasons. The one is that the request data method is expecting a callback which takes in an object, and over here the onMapDataReceived method is taking in a height map instead. So let's change this argument type to be an object. Now we know that this object can be converted to a height map because we specifically passed in this generate height map method and used this as our callback. So we're confident in saying that this can be converted to a height map, like so. And I'm just going to call this height map object, and this whole method, I don't want it to be called onMapDataReceived, instead it's on height map received, and this should be called height map as well, and the bool should be height map received. Okay, now there's one more problem with the way this is currently set up, and that is that the request data method is expecting the generate data method to have a return type of object and take in no parameters. Now our generateHeightMap method has a return type of heightMap and takes in a whole bunch of parameters. So the return type isn't a problem because it will be able to automatically cast just about anything to an object, but these parameters definitely are a problem. Now, one thing you might imagine doing is creating a new method which returns a heightMap, and this can just be called generateHeightMap. This takes in no parameters, and all it does is it calls this method. So if we now pass in generateHeightMap over here, we're passing in a method that returns a heightMap and which takes in no parameters. So that would be perfectly legal. And indeed, there's nothing wrong with doing it this way. You might think it's actually a cleaner way than the way I'm going to do it, since at least now we don't have this super long line going off the edge of the screen. But I'd prefer to not have to make this separate method here. Instead, I'm going to use a Lambda expression, and it's going to basically be doing exactly the same thing, except we're declaring that new method in line. So we make an empty pair of parentheses to say that this is a method that takes in no parameters, and then we use the Lambda operator, so an equal sign followed by this arrow, and then we say that this is what the function returns. Alright, now the other place we're going to be getting complaints is down in the level of detail mesh class, where we're requesting this mesh data. So here I want to say threaded data requester.request data, and I'm going to pass in a call using the same Lambda expression idea to mesh generator.generate terrain mesh. I want to pass in the heightMap as well as the mesh settings and level of detail. So we've already got a heightMap reference over here. I'm just going to rename this to heightMap, and then we'll want to also take in mesh settings like so, and then here we can pass in heightMap.values and the mesh settings and then the level of detail. Alright, and then the callback is the onMeshDataReceived method, and here we just need to change this to an object. I'll rename this meshData object, and here before we call createMesh, I'll just cast this to a mesh data. Alright, now I'd very much like to move this terrain chunk class to a separate file because this endless terrain script is getting very big. So I'm just going to grab this and I'm going to select, probably include the level of detail mesh here. I'm going to cut that out, go into Unity, create a new C# script called terrain chunk, open that up, and just paste all of that in here. Okay, to get access to vector2's game objects and so forth, we're going to need to say using Unity engine up at the top here, and then to be able to get access to this level of detail info class, I'm going to go into endless terrain and just move it outside of the endless terrain class, so it's a standalone struct. So if we save that, we can then come back into the terrain chunk class and just fix the remaining problems. So first of all, we no longer have access to the viewer position, so let's just take in a transform for the viewer in the constructor here, and I'll just save this outside, transform viewer, and assign it. Okay, and then I'll make a little vector2 accessor called the viewer position, and this just returns a new vector2 from the viewer's position on the x and z axes. Alright, then the max view distance is simply the visible distance threshold of the last element in the detail levels array. So we can just create a float somewhere here, max view distance, and we can assign to it in the constructor max view distance is equal to detail levels with an index of detail levels.length -1, so the last element, and we get its visible distance threshold. Alright, now the next issue is adding the terrain chunk to the visible terrain chunks list, which is in the endless terrain script. Now, I don't want this terrain chunk class to be sort of accessing the endless terrain script. I'd rather have an event called something like onVisibilityChanged, and endless terrain subscribes to that event and then actually adds the chunk itself or removes it, depending on the visibility. So up here, I'm going to create a public event system.action. It's going to have two parameters. The one will be a terrain chunk, and the other one will be a bool for its visibility. I'll just call this onVisibilityChanged. Alright, so over here, instead of adding or removing the terrain chunk, we'll just say that if that onVisibilityChanged event is not null, then we're going to invoke it, passing in this terrain chunk, as well as the visible bool. And perhaps we should just put this after the visibility has actually been set. Alright, the last thing is we need access to the collider generation distance threshold, which is a constant value stored in the endless terrain script over here, and that actually completely belongs to the terrain chunk, so I'm just going to paste it in at the top here. Alright, so let's now save this and set things up in the endless terrain script. Now, first of all, endless terrain is actually going to have a name change. It's going to be called the terrain generator, because later on it's going to be responsible not just for endless terrain, but also for generating fixed size maps. Alright, now the map generator is going to no longer exist quite shortly, so I'm going to delete that reference and delete that from there. Now, to get mesh settings and the height map settings and so on, the terrain generator script is actually going to have its own references to those, so a public mesh settings and a public height map settings, and also the third one, the texture data, which could also be called the texture settings, maybe, to keep things consistent. Alright, so now instead of referring to the map generator, we just get our own mesh settings over there. Alright, and some quick cleanup. We no longer need to store this max view distance variable, and the viewer position doesn't need to be static anymore, since it's, or public for that matter, since it's no longer accessed by the terrain chunk. And our visible terrain chunks list also doesn't need to be static any longer. Okay, so we are using the max view distance variable over here, but it doesn't need to leave the start method, so just define it there. Alright, now let's go down to where we're creating a new terrain chunk. I'm just going to cut this onto a separate line. I'll say terrain chunk, new chunk is equal to that. And of course the constructor has changed fairly significantly. We need to now, let's see, pass in the height map settings, as well as the mesh settings. And then the other thing that's changed is we need to pass in the viewer transform over here. Alright, so now we pass the new chunk into the dictionaries add method, and then we're also going to want to subscribe to that onVisibilityChanged event. So over here, let's create a void onVisibilityChanged. Let me call this onTerrainChunkVisibilityChanged, and this takes in a terrain chunk and a bool is visible. And we can say if the terrain chunk is now visible, then we want to add it to the list. So we say visible terrain chunks dot add the given chunk. Otherwise, we of course remove it. Visible terrain chunks dot remove chunk. Alright, so to subscribe that, we just say new chunk dot onVisibilityChanged plus equals our onTerrainChunkVisibilityChanged. Okay, now I'd like to make sure that this method is subscribed to the event before the height map is requested, because if the height map gets received and we update the terrain chunk before that method is subscribed to the event, then we might get a change in visibility over here without it being subscribed. So it's going to miss a call, and that would be disastrous. So to get around this problem, I'm going to make a public void called load. And this line where we request the data is going to go into the load method, and then the terrain generator, once it's subscribed to that event, will say new chunk.load. Okay, so let me save this and make sure it's all working. Maybe got an error or two. Okay, so I forgot to pass in the parameters we need for request mesh. We need to pass in the mesh settings. And I think there's another request mesh call over here in the update collision mesh. So just pass in the mesh settings here as well. And then we should be good. All right, so now on the map generator, it's lost its reference to the endless terrain script since we changed its name. So let me just go here. What did we call it? Terrain generator. All right. And let me set this up. So you're going to have to pass in the height map, the texture data, and the mesh settings. And then, has this retained its values? Looks like it has. One thing I must quickly do actually is in the map generator, recall we have the start method to apply the texture data to the material and update the mesh heights at the beginning of the game. That's now going to be moved to the terrain generator, to the start method over here. So this is going to be called texture settings instead of texture data. And the terrain material, I named map material here for some reason. All right, so save that, save the map generator, and let's try this out now. So I'll just press play. And a whole lot of nothing is happening. All right, that had me confused for a little while, but just forgotten to add the threaded data requester to the scene that needs to be in there. So now if I play this, hopefully it's going to work this time. So we've created all of these terrain chunks, and I'm just going to top view here and try moving the viewer around. Okay, so that seems to be working, and no chunks are getting left behind. Great. So last thing I want to do is move the remaining map generator functionality into the map display class and then get rid of the map generator. Okay, so let me open up this map display class, which I'm going to rename to map preview, and overwrite, and then heading into the map generator, and I'm going to grab these different variables and paste them in somewhere over here. And I also want the onValues updated and the draw map in editor and the onValidate method. So grab those and paste them in. All right, so we no longer need a reference to map display since this is all happening in one class. And then just to organize this a little differently, I'm going to put these onValues updated and the onValidate methods right at the bottom, since those are the least interesting to me. All right, and then we don't need to change the scale of the mesh object anymore, since once again that's happening in the mesh these days. All right, now I'd also like to make it so that when we call the drawTexture method, it automatically enables the texture object, so textureRenderer.gameObject.setActive true, and it disables the preview mesh, so I'll say meshFilter.gameObject.setActive false, and then just the other way around if we ask it to draw mesh, so set the texture object to false and the mesh to true. Okay, let's save that and try it out. Got some errors. Okay, the whole map generator class is going to go. I'll delete it now, say farewell. And then over here, we need to link up to the map preview. I don't know if it'll let me do that with all the errors. Okay, we've got errors in this editor script. This was the editor for the map generator, but now it's going to be an editor for the map preview. So just change all instances of map generator to map preview, like so. And I'll rename this to map preview and call this the map preview editor. Alright, so now I'll save that, and hopefully that's all the errors. Alright, so I'm going to remove the old map generator from there, and I'm going to put this map preview on a separate object. So I'm just going to say copy component and then remove component and create empty. Let me just put this at 0, 0, 0. I'll bring it up to the top here. I'll call this the map preview. And this is going to hold, I don't know what this quad object is, I'm going to delete that. It's going to hold the texture plane and the preview mesh. Let me just rename these to preview texture and preview mesh. And then I'm going to paste the map preview script on there. And let me quickly add these assets, height map settings and mesh settings. Oops. And I'll also want to add the material. That's the mesh material, I think. Okay, so then let me say auto update, and now it's drawing the noise map. And if I change it to fall off map, it draws the fall off map, and on mesh, it will draw the actual mesh. Now, it seems to have not updated the texture values, so let me just go into the map preview and just say that when we ask it to draw the map in the editor, I'm just going to ask it to go texture data dot apply to material, and I'll pass in the terrain material. Okay, let's try this time. Alright, seems to be working, and if we change the level of detail, that works as well. Okay, one thing you might have noticed is that when I asked it to draw the noise, you can see it's very sort of whited out. There's a very high contrast, and that's just because when we're asking it to draw the height map, we're giving it the height map values, but the height map values are no longer between 0 and 1. This is including the height multiplier and the height curve. So instead of passing in just the values to the texture from height map method, I'm going to pass in the entire height map. And so then in texture from height map, I'm going to change this to an actual height map object. And to get the width and height, it can just use the values. Alright, and then when it is getting the value over here, first of all we have to say dot values, but it's going to now squash this into a range between 0 and 1 by using the inverse lerp function between height map dot min value and height map dot max value given the height map value. Okay, so now when we give it the fall off map, we have to convert that to a height map. So we can just say new height map object, and the fall off map is in the range 0 to 1, so we can just say the min value is 0 and the max value is 1, like so. Alright, now we should see our noise map properly, and the fall off map should still work, and the mesh should work as well. Very last thing, the noise map is being drawn really big, so I think that when we're setting the size of this plane, just divide that by a constant 10, and that should just be a little bit more reasonable. Cool. The preview mesh has got a hide on play script attached, so it deactivates when we enter play mode. Just quickly going to make sure that the preview texture has one of those as well. So just add hide on play. That is now everything. So I'm going to save and say goodbye. Until next time, cheers.